Hey guys, in this video, we're going to be learning about hypothesis testing, which is a really important chapter because it is the foundation for many other topics that we're going to be seeing in a business statistics course. And so here's really the introduction to hypothesis testing. Now, before we get into the details, I want you guys to really understand just fundamentally what a hypothesis is. A hypothesis is an idea that you have, and we have to learn how to test these ideas, these hypotheses, uh, taking a scientific or a statistical approach. How do you test a belief? And I'll give you an example. I could say, or I believe, that if you take my course, or out of all the students who take my course, 99% will pass. That's a hypothesis, and I'm going to teach you guys in this video how you could test that. Or I could say the average grade of my students is over 70. It's a hypothesis. I believe that to be true, but we can test it. So that's what we're seeing here. Now, there are many different types of hypothesis tests. In this chapter, we're going to learn two. We're going to learn how to test a hypothesis about a mean, about a population mean, or how to test a hypothesis about a population proportion. Okay. Now, before we get into that, you have to understand that there's always two hypotheses. There's what we call the null hypothesis. This null hypothesis is assumed true. It is not what you're trying to prove, right? There's always one hypothesis that is assumed to be true, and then there's the alternate hypothesis, which is what you are trying to prove. Think about, and we always use this this comparison. If you're accused of a crime, right? You go to court, the judge, the jury, right? They are all trying to figure out whether or not you did it. So you remember how, I'm sure you've heard it, you're innocent until proven guilty. What does that mean? It means that your innocence is assumed true, right? And we are trying to prove that you're guilty. We're not trying to prove that you're innocent. Your lawyer is not trying to prove that you're innocent. They're just trying to prove you didn't do it. And so that's the concept of a null hypothesis. In every hypothesis test, there's the two versions. There's one hypothesis that is assumed to be true, that's the null, and then there's the alternate, which is what we are trying to prove. We are trying to gather evidence to try to say, no, we have enough evidence to say that this person is actually guilty. Okay. So we're going to see three types of tests in terms of their direction. We're going to see lower tail tests. A lower tail test is when you're trying to prove that something is less than something. An upper tail test is when you're trying to prove that something is more than something. And a two tail test is when you're trying to prove that something is either more or less. Okay, I mean, this might seem very abstract for now, but we'll come back to these pages and we'll talk about it. So there are 5 steps to every hypothesis test. The first one is to state your hypothesis, and this is the most important step because you want to make sure you don't mix it up. If you misstate your hypothesis, then every step you take after will be wrong because you'll be doing it based on an incorrect hypothesis. Rejection areas, p-values, all that good stuff. We'll talk about that as we actually start solving exercises. The best way to learn this is to really get into it. So I want you to meet me, even this stuff, like we'll skip this for now. I want you to meet me here. The first hypothesis test we're going to see is how to test a hypothesis about a population mean where we have the standard deviation of the population. So we saw this in the previous chapter. When sigma is known, we use a z table, z-scores and all that stuff. And then later on, we'll see what we do if the sigma is unknown, right? We're going to use t. But just to give you some context, this would be when I said in my example of the average grade of my students is over a 70, that was a claim or a hypothesis about an average. On an average, I said the average grade is more than 70. So this is how you would test that. So let's take a look at this question, and I'm going to walk you through the thought process and the steps. You've been hired by Toyota to determine if a marketing campaign is pushing the limits of false advertising. The ad campaign is claiming that the new Sequoia gets at least 27 miles per gallon. You see, this is what they are claiming, that it gets at least 27 miles per gallon on the highway. The standard deviation is known to be 2.5. See? The standard deviation is known to be 2.5. That's your population standard deviation. So at that moment, sigma is known. You've been given a sample of 20 cars. This is your sample size to determine if they should run the ad. And you found that the gas mileage on average was 24.3. So this is your sample average. And this is how you test a hypothesis, guys. You go and take a sample and you test it for whatever it is you're interested in. And you look at the number. So we're saying here we're testing gas mileage. The claim was about gas mileage. So I went and took a sample of 20 cars and I measured their gas mileage. And I found the average gas mileage was 24.3. Now that's below the 27 that they're claiming, but we don't want to come to a conclusion yet, right? That looks to me like we have some evidence that their claim is wrong, but it has to be enough evidence. Just like when you're accused of a crime, just having a little bit of evidence is not enough to throw you in prison. I always use the same example. It's a bit extreme. If somebody broke into my house and stole my TV, and I accused you of doing it, I said, you did it, and my evidence is that you and I live in the same city, technically, yes. That's some evidence, but it wouldn't be enough to say you did it. You drive a black car and there was a black car parked outside my house. Okay, now that's still some evidence, but it wouldn't be enough to put you in jail. You see, just having some evidence is not enough. We have to have enough evidence. And what we're going to learn in this chapter is how to measure whether or not evidence is enough. Okay. So, is there enough evidence using a 5% level of significance to reject the claim? So here are the 5 steps. Step 1, state your hypothesis. Now, the hypothesis about a mean should always be written as mu, either greater than, less than, or right? So it's mu, at least 27. At least means greater than or equal to 27. This is the claim. Now, this next thing I'm going to say is very important. The claim, or what is stated in the question, is not necessarily your null hypothesis. It's not necessarily your alternate hypothesis. This is how you choose. If there is an equality in it, any one of those symbols, that's automatically the null hypothesis. So in this case, because they said at least, this is our null hypothesis. We are going to assume that this is true, and the alternate will not have the equality. So if this is the claim, and this is our null hypothesis, you have to state the alternate as the opposite of that, or the complement of that. So we are trying to prove that the average is actually less than 27. They're claiming it's at least 27. That's the null hypothesis. We are going to try and prove that it's less than 27. Okay? That was step 1. Step 2, choosing the correct test. Now, we've already established that sigma is known. So we're going to use a Z test. But is this going to be a left tail test, a right tail test, or a two tail test? That's the next thing to see. This is actually very simple. You always look at your HA. Because remember, I'm just trying to add a page here. Remember that the alternate hypothesis is ultimately what we are trying to prove. And so because we're trying to prove that it's less than 27, this is a lower tail test. We're just going to put a line right here and shade this area. This area is called the rejection area. You'll see why in a second. This is called the rejection area. The area itself is equal to your alpha, and the line is your critical value. These are all things we saw in the previous chapter. So in this case, because they said to use a 5% level of significance, that is the area of this tail. This is the 5%. Okay, so we've set it up. Your third step is you need to find your critical value. Like, where is that line? And we learned how to do this when we were doing interval estimation. So it's the same idea. You're going to take that alpha, that tail of 0.05, and go look it up in your z-score table. So an alpha of 0.05, if you look it up in the table, the z-score that corresponds to that is negative 1.645. Okay, open up your z-tables, go to 0.05. Okay, I'll find mine. Okay, here it is. So in this chapter, the signs do matter. So I'm looking up 0.05, which you'll see that it's right in between those two. So if you follow it out, it's negative 1.64 and 1.65, and the average of that, or the middle of that, would be 1.645. So the critical value that corresponds to a tail of 5% is 1.645. What do I do with that, though? It tells me that this line, this line right here, is a z-score of 1.645. Okay. Step 4. Your evidence. We call this the test statistic. We'll talk about all these things. We're just walking through the steps right now. Statistic. This is the z-score, and it's actually the same formula as when we did sampling distribution. So x bar minus mu divided by the standard error, which is the standard deviation over the root of n. So x bar, that's always given to you in the question. So we took a sample of 20 cars and found an average of 24.3. The mu here is the hypothesized mean from the hypothesis, right? So 27. The standard deviation is 2.5. And the sample size was 20. Okay, let's do the math here. 24.3 minus 27 divided by 2.5 square root of 20. I got negative 4.83. Okay. Good. Okay, so what does all this stuff mean, right? It's just a bunch of numbers. You found a z-score of negative 4.83. Think of this as your evidence. This is the evidence you gathered. This critical value represents the cutoff between having enough evidence. So if you're in the rejection area, there's enough evidence. And if you're not in the rejection area, there's not enough evidence. So we're going to compare our test statistic and check if it is in the rejection area. And it is, right? 4.83, negative 4.83 is much more to the left than that line, which is negative 1.645. So we're like somewhere here. If your test statistic lies in the rejection area, it means that you have enough evidence to reject the null hypothesis in favor of the alternate. It's like, again, when you're accused of a crime, right? Once you have enough evidence, we can reject your innocence in favor of a guilty verdict. That's the concept here. If your test statistic had not been enough to push you into that rejection area, then we would say there's not enough evidence. So here we're going to say, and we can now draw a conclusion. Since negative 4.83 is less than negative 1.645, we reject, this is how you do it, okay? You reject HO. So in terms of stating your first conclusion, which is this one, you either reject HO, you reject the null hypothesis, or you don't reject it. I know it sounds funny, but never say here that you accept HA. You either reject HO or you don't. Okay? And then the interpretation, if ever you were asked to interpret it, would be this. We're basically saying that at a 5% level of significance, there is enough evidence to conclude that Toyota's claim is wrong. The car is, that Toyota's claim is wrong. Or that you could say, or that the gas mileage is less than 27. So let me break this down, okay? There's a few things you want to have in your conclusion, in your interpretation. You want to have your level of significance. Here, there's two scenarios, and this is really the only thing you would change. If you reject, which we did, then you have enough evidence. If you don't reject, so if you fail to reject, then you say you do not have enough evidence. There is not enough evidence. Everything else would stay exactly the same. And then the last bit, you basically just want to state your HA. Always. Always state HA. You're basically saying you have enough evidence to conclude HA, or you don't have enough evidence to conclude HA. That's how you would write the correct interpretation. And that's how you take a statistical approach to testing a hypothesis. So we now have evidence where we can say that their claim is wrong with a very high level of confidence. In this case, the level of confidence would be 95% because we're using that 5% alpha. And that's the procedure of finding or of doing a hypothesis test. Now, let's get into the slightly more, the secondary things. I placed my test statistic, and I'm going to erase some of this stuff because it's getting messy, but I placed my test statistic right here, right? That was negative 4.83. There's this little tail beyond my test statistic. That little tail beyond your test statistic has a name. This is called a p-value. P stands for probability. And the next thing would be to learn is how to find that. And actually, you already know how to find it. We've done this. It is the probability. It's basically the probability that your z will be less than negative 4.83. So you just have to go look this number up in the table. That's your p-value. So if we go into our z tables, our table doesn't actually go that far. It stops at negative 3.99. And look what it is at negative 3.99. It's basically 0.00003. So anything less than that, you can approximate as 0. So we can say here that the probability of being in that little tail, which is less than, that would be approximately 0. So that's the p-value. That's what we call it. We call it a p-value. Now, what do we use it for? A p-value is just another way to state your evidence. And let me just go back to the page here, okay? If your p-value is less than your alpha, then we reject HO. So in our case, our p-value was approximately 0, which is less than alpha of 5%, so we reject. But what is, because if you're looking at this saying, well, why would I do it this way? The p-value is meaningful because the smaller it is, the better or the stronger your evidence, okay? And I have that, do I have that written somewhere? No. Well, let's write it. The smaller the p-value, the stronger the evidence. Okay, so it's something to know. So if you were faced with, a p-value of let's say you had a p-value of 1% and another p-value of 5%, it means that the evidence in the first one is better than the evidence in the second one, is stronger. For your exams, you have to know how to find it. You have to know how to interpret it in terms of alpha. You compare it to alpha. So if it's more than alpha, it's not, you don't reject. If it's less than alpha, you do reject. And then that's pretty much it. Okay, let's do another one. Now we'll see how to, actually, before we do that, let's talk about this tip here. So now that you've seen one test, you realize, or maybe you realize there's 4 possible outcomes. You could correctly reject, you could correctly fail to reject, but there's also a chance you make an error. And this is what I want to talk about, the 2 different types of errors when it comes to hypothesis testing. A type 1 error happens when you reject the null hypothesis and the null hypothesis ends up being true. Like in our test with Toyota, we rejected HO. We said, no, their claim is wrong because that's what our evidence pointed us towards. Our evidence said they're wrong. But what if they were actually right? It's possible, right? That would be called a type 1 error. When you conclude that the HO is incorrect, when in fact it is correct, we call that a type 1 error. And there's a probability there. The probability of a type 1 error is the alpha. Where is it? Here, the probability of making a type 1 error is called alpha. And then there's other situations where you don't reject the hypothesis, but it turns out that it ends up being false. So where your conclusion is that you did not have enough evidence to reject HO, and in fact, HO was actually true, was actually false, we would call that a type 2 error. We'll talk about this one in a second when we do a test that doesn't have it, that doesn't have a rejection. For now, I would just memorize them. So let's do another one, this time when we don't have the standard deviation of the population. So look, a local bakery claims that the mean weight of its signature chocolate cake is 2.5 kilos. Suspecting that the actual mean weight is less than this, a food critic decides to perform a hypothesis test. She buys 30 of these chocolate cakes, so there's your sample size, over a month and finds that their mean weight is 2.45. So that is your sample average with a standard deviation of 0.15. Now, listen up, this part's very important. I have a standard deviation here, but look at how they gave it to you in terms of like where it is in the sentence. They said that she bought 30 chocolate cakes and that their mean was 2.45 and the standard deviation was 0.15, which means that's the standard deviation not of the entire population of cakes, but of these 30 cakes, which means this is a sample standard deviation, not a population standard deviation. It's an S, not a sigma. So sigma is unknown. Compare that to the Toyota question if I go back. It said the standard deviation is known to be 2.5 miles per gallon on this model. We never even talked about a sample. We just said this model has this standard deviation. So you see that one is the standard deviation of the population. And this is why you want to be careful when you're reading your questions. Now, a little tip. Most of the time, it belongs to the sample. I'm not saying it's always going to be like that, but most of the time, the standard deviation, if you read it carefully, is from the sample. So we're going to use the t table. And the only thing that's going to change is your fourth, is where you find your critical value, and then that's it. Okay, so using a significance level of 5%, test the critic's suspicion that the mean weight is less than the claimed weight. So we're trying to test that if the mean is less than 2.5. Is this HO or HA? Is this the null hypothesis that we assume true, or is it the alternate hypothesis that we're trying to prove? Think about what I said earlier. Look at the sign. There's no equality in this, which means this is your HA. This is the alternate. The HA does not have it, and therefore you have to set your null to its complement. And this is why I said what's stated in the question is not necessarily HO or it's not necessarily HA. It could be either one. You have to know based on the sign. Okay, now step 1 done. Step 2, let's choose the right test. Again, you're trying to test, always look at your HA. It always tells you the direction of your test. You're trying to test that it's less, so this again is a left tail test. So we have here our rejection area. The alpha is 5%, so this whole area is 5%. And right here, that's your critical value. Step 3. We are going to find the t that corresponds to an alpha of 5%. But for this, you have to remember that degrees of freedom when you're doing this is sample size minus 1. So because we had a sample of 30, 30 minus 1 is 29. So let's go to our tables. Go to your t tables. So t would be this one here. 0.05 and 29. So that is 1.699. That is your critical value. The tail tells you the column. The degree of freedom is n minus 1, 1.699. Now the thing about the t table is that it's always one-sided. So pay attention here, it's important. This is not 1.699. It's actually negative 1.699 because it's on the left side of your midpoint, right? Of the middle of your bell curve. We're on the left. Everything on the left is negative, but the table won't give you that. You have to put the negative on yourself. So what I'm saying is this line is negative 1.699. Okay, now we check our evidence. Now we check our test statistic. So we're going to do the t observed, which is x bar minus mu divided by the standard deviation over root n. So we found an average of 2.45 in the mean, in the sample. So 2.45. The hypothesis was 2.5. Standard deviation was 0.15. And the sample size was 30. Okay, so let's see what we get as our t observed. (2.45 minus 2.5 divided by 0.15 over the square root of 30. Negative 1.825 or negative 1.83. So take a look. That again is beyond 1.699, which means it is in the rejection area. Sorry, this was step 4, not 3. So your step 5 now, the conclusion is that we are going to reject. So we're going to say that negative 1.825 is less than negative 1.699. Therefore, we reject the HO. We reject HO in favor of HA. So we can say, again, that at a 5% level of significance, because we're rejecting, we say there is enough evidence. So there is enough evidence to conclude that, and then you state your HA. The mean weight of the chocolate cake is less than 2.5. That the mean weight is less than 2.5 kilos. Okay, so that's how we tested, right? Same 5 steps. What is the p-value? Now, when you're trying to find the p-value using a t-test, it's a little bit different than just going and looking it up the way we did before. So I want to walk you through the steps, and this is very steppy, so just, again, pay attention to your steps. So remember where the p-value is. The p-value, we have our critical value, and then we have our test statistic. Our test statistic was negative 1.825. The p-value is the area that is beyond your test statistic. That area there, that's called the p-value. So the way that you find it with the t-table is like this. You need to go back to the same degrees of freedom. So we had used 29 degrees of freedom and look for your test statistic. Let me show you what I mean. Go to 29 and look for 1.825. So you have to look, and it's going to be between these two, right? It's between those two. So then you follow it up, because you want to know between what 2 columns is it? 0.05 and 0.025. Okay, let me write that down. So 0.025 and 0.5. So what you found here is that area that I made green, this area here, we don't know exactly what that area is, but we do know that it is between 2.5% and 5%. That's the p-value. The p-value is the area, where the area is somewhere between 2.5% and 5%. That probability, right? The probability that your t is less than negative 1.825 is somewhere between 2.5% and 5%. You're not going to find an exact number without Excel. So obviously on an exam where you're doing this by hand, you don't have to worry about that. But this is the approach. You take your degrees of freedom that you used, you look up your test statistic, and then you tell me, a range of areas that the p-value would fall within.